Hi there, folks. Today we're looking at the probability of dependent and independent events, and really this is a category of compound probabilities, all right? So when we're talking about dependent and independent events, these are a special kind of compound probabilities. So let's talk about compound probabilities. Compound probabilities are basically when we have more than one thing that we're looking at the same time. And we either want both of those things to happen, so we link it with the word and, or we want one or the other of those two things to happen, so we link it with the word or. Okay, so compound events, two or more events linked by the word and or the word or. For dependent and independent events, we're going to focus on those and probabilities, all right? So these are all compound probabilities because we have more than one thing that we want to happen, all right? And we either want both things to happen, so we say and, or we want one or the other, so we say or. So with the and probabilities, so this is for independent events, we just say if I want the probability of A and B, I take the probability of A times the probability of B, all right? And again, this is just two things. So if I say, hey, what's the probability of the first thing happening? Now, separately, what's the probability of the second thing happening? Well, if I want the probability of both of those things happening, I want the probability of this thing and this thing, I just take the two separate probabilities and I multiply those two fractions together, okay? For example, look at something like this guy. If you roll a six-sided dice, or really it should be a six-sided die, what is the probability that you will roll a 5 and then roll a 3? And so again, I just have two separate probabilities happening, and we're linking those two things with the word and. So I just say, hey, what's the probability of rolling a 5? Well, that's 1 out of the 6 options. So the probability of rolling a 5 is 1 out of 6. And then we say, okay, what's the probability of rolling a 3? Well, there's one of those out of the 6 options, so that's also 1 out of 6. So if I wanted the probability of rolling a 5 and rolling a 3, I multiply these two probabilities. So that gives me 1 over 36. Remember, when you multiply fractions, it's numerator times the numerator, denominator times the denominator. And that's it. If I look at the next one, it says, what is the probability that you will roll an even number on each? So I'm rolling two different, I'm rolling a pair of dice here. I want to know the probability of rolling an even number on each. Well, as you look through here, the word and is not listed, but the word and is implied here. If I want to roll an even number on each, that means I need an even number on the first die and an even number on the second time. So that word and is implied. It's not necessarily about the word, it's about the situation. Do I want both things happening? Yes, it's an and. All right. If I want one or the other, it would be an or. So for this one, to roll an even on the first die, so again, an even number, there are 3 even numbers when you roll that thing, so it's 3 out of 6. And then the probability of rolling an even number on the second die is also 3 out of 6. If I want both of these things to happen, if it's an and probability, I multiply the two, and I'm going to reduce each of these fractions first. That's 1/2 times 1/2, so the probability becomes 1/4. So I'm just working out the probability of each, but the and tells me to multiply those probabilities. But look at this one. It says a bag contains 3 red, 5 blue, and 2 orange marbles. If you pull 2 marbles one at a time with replacement, what's the probability of blue then red? And then it also asks us what's the probability of orange then red. And there's the key to this thing right here is with replacement. What does that mean? Let's talk about that. With replacement means I reach in there, I pull out a marble, I see what it looks like, but then I put the marble back. I replace the marble, I put it back in the bag. And that makes these independent events. Okay. See, independent events are events that do not affect one another. Like in the previous examples, we were rolling two separate die. Well, those don't affect one another because what I get on one doesn't affect what I can get on the other. And here, if I didn't replace that marble, it would change how many marbles are in the bag. So that means the first thing would have an effect on the second thing. All right. So that with replacement is important. Okay. I pull the marble out, I look at it, I put it back in. All right. So then when I look at this first example, the probability of blue, there are 5 blue marbles out of a total of 10 marbles. And then the red marbles, so I pull the blue marble out, I put it back in. There are 3 red marbles out of a total of 10 marbles. Okay, and it's still 10 because I put that first marble back. And again, the word and is not written here, but it's implied. I want a blue marble and then a red marble, okay? We would never say a blue marble or then a red. That doesn't make sense, all right? But think about the situation. I want both of these things to happen. I want a blue marble and a red marble, so that's an and probability I'm going to multiply. And once again, I want to simplify this fraction first. So let's see, that's a 1/2 times a 3 over 10. So that gives me a 3 out of 20. So the probability of getting those two things is a 3 out of 20. All right. The next one, an orange marble, would be 2 out of 10. The probability of a red marble would be 3 out of 10. And again, the reason it's 3 out of 10 is because I put that first marble back after I looked at it. So there's still 10 marbles in the bag. That's going to become important later. The word and is implied here. I want both of these things. So now let's reduce and do our multiplication. So that gives me a 3 out of 50. Okay, but again, not much different than what we were doing. I'm still working out each probability individually, but now because the and, I want both of those things to happen, I multiply the two. Let's talk about dependent events. The difference between dependent and independent is really just a matter of a little bit of imagination. We have to imagine that the first thing happened, and that's it. It's literally still the same thing, but we have to think about the situation. We have to imagine what's going on. Okay? So, and probability for dependent events is the probability of A then B. We have to do the probability of A times the probability of B after A. All right. And that's the same thing we were just doing, except with a little bit of imagination. So what it's saying is we take the probability of the first thing. All right. No problem. That's not any different. But then I imagine that that first thing happened. And if that first thing had already happened, now what's the probability of the second thing happening? Okay. Because they're dependent events, whatever happened first affects what's going to happen second. Okay, it changes the possibilities in terms of the outcomes. See, the previous example, independent, they have no effect on one another, so I don't need to imagine what happened. Okay, but here, if they're dependent event, it means that the first event happening has a direct effect, a direct impact on what happened, what could happen for the second event. So I have to imagine that that first thing has happened. Okay, for example, let's take a look at an example here. It says a jar contains 5 green, 10 red, and 7 blue marbles. 2 marbles are pulled one at a time. Sorry, a little typo there. One at a time without replacement this time. And so that's the key here. Without replacement means once I pull that first marble out, I do not put it back in the jar. Okay? So here, the probability of green, same thing that we've always done. There are 5 green marbles out of a total of looks like 22 marbles. So the probability of green is 5 out of 22, but now I have to imagine that that has happened. I have to imagine that I pulled a green marble out of that jar. And if I pulled a green marble out of that jar, if I use my imagination here, that means now there's only 4 green marbles left, right? So when I do the probability of red, there are still 10 red marbles, but because there's only 4 greens left, I only have 21 marbles total left in the jar. And see, that's the difference between dependent and independent, okay? The dependent here, the values changed because of what happened, okay? As opposed to independent where they don't affect one another. And of course, I can cross-reduce. Remember, whenever we have fractions, reduce these guys. They're each divisible by 2, so that's a 5 over 11. And I think that's all that simplifies. So now I multiply straight across. That's a 25 over, it looks like a 231. So 25 over 231. Okay? But now I got to hit the reset button on this one. All right. So this one, the probability of a blue marble, then a green marble. So the probability of a blue marble, let's see, there are 7 blue marbles out of, once again, 22 total. But now I have to imagine that this first thing has happened. So imagine I took a blue marble out. Now there's only 6 of them, right? So now the probability of a green marble, well, there's 5 green marbles, but now there's only 21 marbles total. I don't know why I put an equal sign there. This is an and probability, so I want to multiply. And now, of course, I can reduce the 7 and the 21 reduced to a 1 and a 3. And now I multiply straight across. That gives me a 5 over 66. Okay, but again, it's just a little bit of imagination. Let me erase that, hit the reset button again. This one, the probability of red then red. So again, the probability of a red marble, there are 10 red marbles out of 22 marbles total. But now imagine that I took out one of those red marbles. That means there's only 9 left. I took one out. So now the probability of a red marble is 9, because there's 9 red marbles out of 21. And once again, I can reduce the 10 over 22 reduces to a 5 over 11. The 9 over 21 reduces to a 3 over 7. And now I multiply straight across. That's a 15 over 77. But again, I'm just multiplying fractions. Okay. Again, let me hit the reset button here. All right, back to the start. The probability of a blue marble, that's 7 out of the 22. But now imagine that I've taken out one of those blue marbles, so now there's only 6 blue marbles left. So now the probability of a blue marble is 6 out of 21. I have to use my imagination. I have to pretend that that first thing happened. And now I can start reducing. I can cross-reduce. That's a 1 and a 3. The 6 and the 22 I can reduce to an 11 and a 3. Oh, and then I could cross out these 3's to a 1 and a 1. And then multiply straight across. You can, when you're multiplying fractions, you can multiply straight across and then reduce the fraction, but that ends up being more work because you have larger numbers to reduce. You can always reduce individual fractions. You can always cross-reduce when you're multiplying fractions, but only when you're multiplying fractions. This one, a red and a blue die are rolled. What is the probability of the red being an odd number and the blue being greater than 4? So once again, I want both of these things to happen. It's an and probability, and these are independent events. What I get on the red die does not affect the possibilities for what I can get on the blue die. Okay, so the probability for the red die, let's see, odd number, so that's 3 out of 6. And then the blue die, I want a number that's greater than 4. There are 2 numbers that are greater than 4, 5 and 6, out of the 6 possibilities. And then I want to multiply these. And once again, you can reduce these fractions. That's a 1/2. This guy is a 1/3. And now multiply straight across. The probability is 1 out of 6. I come up with the probabilities, and then the and tells me to multiply. All right? And again, if you just use your imagination, it kind of takes care of whether this thing is dependent or independent. All right? Of this one, a box of chocolates contains 10 milk chocolate, 6 dark chocolate, and 4 white chocolate candies. If selected at random, what is the probability that you eat a milk chocolate followed by a white chocolate? Okay. And so again, we just kind of put ourselves in this situation and say, all right, what's the probability of a milk chocolate? Well, it's 10 out of, looks like a total of 20. So it's 10 out of 20. And so what I'm going to do is I pick out that milk chocolate, I eat it. So now there's only 9 milk chocolates left. I took one out and I ate it, and it was delicious. But you can see that now that this is a set of dependent events because the numbers have changed. All right. And just with a little bit of imagination, we come up with that. So now we're going to multiply. The probability of a white chocolate, there are 4 of those, but there's only 19 of those things left because I ate one. And now I got to start reducing. These guys reduce to a 1 over 2. The 4 and the 2 can reduce to a 2 and a 1. And now I multiply straight across. That's a 2 out of 19. Okay? So dependent versus independent events really is just a matter of using our imaginations. If you just envision what's happening, if you think about the situation, if kind of play it out in your head, that takes care of the dependent versus independent. And then we just have to come up with the 2 probabilities. What's the probability of the first thing? What's the probability of the second thing? And then and tells me to multiply those probabilities. Okay?